All right, welcome back, everybody. Let's do some math. How about that? We said we're on number 10, you said? All right, so this is math 335. This is lecture day 10. Which is convenient because we are starting chapter 10. So 10.1, like all of 10 is 10 in general. Is dealing with quadratic equations. So 10.1 is on solving using factoring and extracting roots. And 10.2 is on completing the square. Oh, that camera got fuzzy. Sorry if you're watching the video online. So extracting roots leads into completing the square. And we've done a lot of factoring already, so I think our better time spent like walking through like the steps to extracting roots, what that means, and then like getting ready for completing the square in here. We got an hour, not a lot of time. So extracting roots. Let's start there. If we have x squared equals, let's say c, then x equals plus or minus the square root of c. I'm going to say real quickly to illustrate this that C2 equals the square root of C1. So if we had x squared equals c squared, right, let me rephrase that. C2 equals square root of C1, there we go. So x2 equals C2 squared. This is really the same thing as saying x squared equals square root of C1 squared, which is C1, which is kind of like what we're talking about here. I just added a 1 subscript. But why do we have the plus or minus? Remember, if we take the square root of something, take the square root of a square, it leads to the absolute value. And absolute value leads to plus or minus. And since C2 equals square root of C1, that's how we get the plus or minus square root of C. Or I just dropped the 1. It stems from that rule with the absolute value signs for square root of a square. So let's look at some examples. Give me a second to finish writing that. Everyone looks like the pin's down. All right. Let's go on. Let's take some examples. let's say like, I don't know, x squared minus 18 equals 0. This isn't a perfect square, so even if I wanted to do like the difference of squares or something like that, it's a little harder to do. But what we can do is we can add 18 to both sides. And then we take the square root. So x equals plus or minus the square root of 18. And we want to simplify. 18 is 9 times 2. Which means we got the square root of a 9 in there. This can turn into 3 root 2. Doing some of that stuff we did with radicals before. Now, interestingly enough, this does show that it is factorable. But let's like look at how it works. Like if we had something where we had like x minus x1 and x minus x2 equals 0, we would see doing the factored form that x equals x1 or x equals x2. And we could go backwards here to get, we can go backwards. So I'll show you with this one, going backwards to get the x squared minus 18. I have x equals 3 square root of 2, or x equals negative square root, or 3 square root of 2. The steps we took to solve it, at least the right equation was like that. So we added x2 to both sides. We're going to undo that. What we're going to do to go backwards on that is just move it back to the other side. If I move this back to the other side by doing minus 3 root 2, I have x minus 3 root 2 equals 0. Or here I would have to add 3 root 2. So x plus 3 root 2 equals 0. And since this goes with the whole 0 product rule, a times b equals 0. So a equals 0 or b equals 0. We tear them apart, but now we're going to put them back together. Let's call that a and let's call that b. We can put this back together and say x minus 3 root 2, which was square root of 18. Let's make this a little bit easier. And this was plus square root of 18. And if you multiply this out, you're going to get x squared minus 18 equals 0, which means those are the factors. Now, are you going to ever be expected to factor like that? No. That's why we're doing the whole extracting roots and completing square and all the stuff, the other stuff we're going to do in this today. And maybe Thursday, I forget what's on Thursday's topics. But like it is doable. You can always start with the equation or the answers and get back to the equation. Any questions on that? Let me give you guys one to try. Try x squared minus 5 equals 0. And then try x squared plus 7 equals 0. Okay. Anybody done?
So
What'd you guys get for the first one?
if it x equals plus or minus √5.
That is what it is. So when we add 5 to both sides. When we take the square root of both sides. Since it's the square root of a square, we gotta do the absolute value thing. Which does turn into, this is like saying the x equals the absolute value of square root of 5. And that'll lead to plus or minus square
Plus
root
or
of 5.
minus is the same thing as absolute value, right?
Yeah, when it's a solution thing, yeah.
So, but whenever there's a, it's called exponent, yeah. Whenever there's an exponent on the x or on that side, you have to do plus or minus for the solution.
When there's an x squared,
Okay, so like,
when you're doing a positive number, there's a plus or minus. Or like a positive even number, there's gonna be a plus or minus. What about this one?
it's equal to plus or minus √7.
No,
When
that's closer. First off, we gotta subtract 7 over. And that is the next, so you'd have x squared equals -7. Square root does give you plus or minus square root of -7, but what happens when we have the square root of a negative number?
was that undefined?
It's not undefined. What's the square root of -1?
Is it just 0?
No. I. So this is x equals plus or minus square root of -1 times 7, which is x equals plus or minus I√7. Yeah, we talked about I a little bit before. As a. I would say don't worry about it, but it is important in a lot of fields. So like knowing how to do it, it's definitely not 0, there is a value here. And like your phones and the fucking electrical currents in the house and anything that really uses electricity in America is like. Was based on the mathematics that involve I. So it is kind of like and it continues to be. It's an important concept.
So whenever it's a negative in that square root, it's gonna be I.
Yeah, you can take the negative out and just put an I out front. That's the general rule. If x equals the square root of -a, x equals I√a. That's just a general rule. Okay. X plus 3 squared minus 16 equals 0. We could multiply this out. Extracting square roots is much quicker. In fact, why don't you guys try doing the extracting roots? What we were doing up here, while I do the long version of multiplying it out, so you see that you get the same answers. And then we'll go over the extracting roots together. You should get 1 and -7. What's the first step?
60.
Gotta get the 16 to the other side, right? What about now? We do the square root. And I should get x plus 3 equals plus or minus 4. So one of these is x plus 3 equals 4, or x plus 3 equals -4. That's really what plus or minus 4 means. And so if we solve this, we subtract 3, we get 1 there, and we subtract 3 here, and we get -7 here. Does that make sense? Now, the left side wasn't too bad. Like, it's not too bad, but this side, there's very little, like, there's no stopping and thinking about the factors. As long as you know square your square roots or how to work with them. There's no decision-making process here. All right. So let's say we had, I don't know, x plus 3 squared equals, no, not do 3, let's do, okay, 8. X plus 8 squared equals 3. Yeah, 3. Let's go with x plus 8 squared equals 3. So doing the same process, we would take the square root. And we would see that x equals -8 plus or minus square root of 3, which is 2 solutions. -8 plus square root of 3, or -8 minus square root of 3. What if we didn't complete the square though? What if we had, if I multiply this out, I have x squared plus 16x plus 64 equals 3. And if I subtract the 3 over, I have x squared plus 16x plus 61 equals 0. Now, there's no way I'm going to recognize that this could equal x plus 8 plus square root of 3 times x plus 8 minus square root of 3. There's no way. There's no way someone's going to be able to do that. So how do we get from here to there, to the solutions? Like we started, it's the same equation. These two are the same. But one of these is a lot easier to work with. This is where the completing the square comes in. We'll start with an easier one. The idea is if we have like x squared plus bx equals 0, add 1/2 b squared to both sides. So we've got a little more than that here, but we'll address that in a second. Let's say we had, I don't know, x squared minus 9x equals 0. Nope, let's do 8x. Let's make it an even number to start with. Now, it's worth noting if we factor this, we would get x times x minus 8 equals 0, which means x equals 0 or x minus 8 equals 0. You get x equals 0 or 8. So this one is doable the other way. But let's do the complete the square thing. What I'm going to do is I'm going to bring this, take this negative 8, divide it by 2, and square it. So this is negative 4 squared. I'm going to add negative 4 squared, which is 16, to both sides. I will have x squared minus 8x plus 16 equals 16. And when you do the complete the square, whatever the hell this was actually goes in the square down here. Those are the same. X squared minus 8x plus 16 factors to x minus 4 squared. Did I lose anyone there? Okay. Everyone okay with seeing that this is 16? Maybe not why it works, but that it is 16. Is everyone following that? We take negative 8 divided by 2, we get negative 4. Negative 4 times negative 4 is 16. If you factor this, we need two numbers that add to 16 or add to negative 8, multiply to 16. And you can go down the list, but if they add to negative 8 and they multiply to a positive number, they both got to be negative. So you can do negative 1 and negative 16, negative 2 and negative 8, negative 4, negative 4. Only one of these ends up being the right combination. So we could do what we've done before, split negative 8x up into two things. Group them. And we had x minus 4 times x minus 4, which is x minus 4 squared. That's the long way of recognizing whatever we got here before we squared it is what goes in the parentheses here. That's like the shortcut. That make sense? Would it save a lot of time just to memorize that rather than try to factor this every time? Because right now, yes, this was easier to solve by factoring. But remember, we're trying to do this one. Which, what? Factor what? Those are the factors, but there's no way you're going to ever guess that. So remember, we're like, well, it may have been easier doing this one. So that's where we're at right now. Then we do our extracting roots. We take the square roots. Are we a little bit better now, James? Mm-hmm. We get x minus 4 here equals plus or minus 4. And we add 4 to both sides, we get x equals 4 plus or minus 4, which is x equals 4 plus 4, which is 8, or x equals 4 minus 4, which is 0. And that's what we saw by just doing factor. Whether or not you memorize the quadratic formula, has everyone heard of it? It's derived using complete the square. I'll actually show that when we start, like if we have time at the end of class today as a segue into the next lecture. Well, this is when there's nothing being added to it. But when there's like the general rule is if we have ax squared plus bx plus c. Divide by a first. And then 2, do the 1/2 b squared. So we're gonna do that on our x squared plus 16x plus 61. Okay. So first step, divide by a. A is the number in front of x squared. A equals 1 in this problem, so step 1 is pointless. Done. Dividing by 1 doesn't change anything. Right? So what we're gonna do is I'm gonna create a little space. And I'll put my plus 61 here equals 0. I'm gonna take the 16 and I'm gonna divide it by 2 and I'm gonna square it. 16 divided by 2 is 8. And then I square it and I get 64. So I'm really adding 64 to both sides. This was 8 squared. So this condenses down to x plus 8 squared. I still have the plus 61 and it's equals 0 plus 64 is 64. Are we okay with that? Lauren?
But you said that when you do the difference of squares. Or no, not
Completing the square.
Completing the squares. That whatever you get goes inside the parentheses at the end.
Which is the 8. But it's before you square
Oh, okay, before you
it.
square.
Before you square it, yeah.
Okay, that's what.
So you square the 16 divided by 2 squared, that turns into 64. You add that to both sides of the equation.
Yeah,
And then the 8 that you get from 16 divided by 2, that goes in the parentheses with the 8.
yeah. And I'm gonna put up that other page where we showed what we started with. We started with x plus 8 squared equals 3. That's when we started completing the square. We're almost there. What do I do? Just subtract 61. Then we do the square roots. And then we subtract 8 from both sides. And we'll get what we had before. You guys ready for another? Sarah, how you doing? Alberto, good? Why don't you guys give it a try and then we'll do it together in like 5 minutes. Something you might find helpful is just to move the 20 right away. Add 20 to both sides. Give me one more minute, we'll do it together. All right. What's my first step here?
Divide by A,
Say that again?
divide by A,
Divide by 8.
but
But what does that do here?
so. You,
So done, but it's good to know.
and then you do 1/2 B squared,
And so let's just take that, cut it in half. So we got -4. So I'm gonna just take this and right away drop this down here into the square. And so we've got -4 squared is 16. So that's what we'll add to both sides. And it makes the right side here 36, right? Everyone get that? Now. Square root, what do I get?
x minus 4 equals plus or minus 6.
Plus or minus 6, yes. Square root of 36 is 6. Now. Add 4 to both sides. When it's something you can add together, you should add together. If there's like a square root or something, you should leave it as plus or minus the square root thing. But in this case, it is 4 plus 6 and 4 minus 6. That's 10 and -2. And we can see if we work backwards here. X equals 10 or x equals -2. If I subtract 10 from both sides, I get x minus 10 equals 0. Add 2 to both sides, I get x plus 2 equals 0. And now with these both equaling 0, I can put them together. And if you multiply this out, we get our x squared minus 8x minus 20. So this was a factorable one. We could have factored, but we're practicing completing the square. Because it always works. Even if it ends up being giving you an I. And factoring doesn't always work, right? Doesn't mean it's the easiest route. There's steps you gotta remember. But was there any like overly complicated step? No, just remembering what to do is the hardest part. We divide by 2, we square numbers. We've learned how to do that in. I think you learn how to square or multiply a number by itself in 6th grade, or before 6th grade. We did some square roots. I don't know what grade you learned that in. But then there was just a lot of arithmetic really after that point.
You know how we add 16 to both sides?
Yeah,
Does the 16 on the left side that we added, does that just get clumped into x minus 4 squared?
yeah,
Yeah,
Cause if you multiply the x minus 4 squared back out,
You get the 16.
you get the 16.
You get x squared minus 8x plus 16. Yeah.
Yeah.
That's what I went on. I just added the 16. to it.
And that's it for that. I'll take a break for, I don't know, till the next class starts.